Okay, in this video, we're going to be solving a trigonometric equation in the interval 0 to 2 pi. Now, because this is written as a difference, if I wanted to try, I could start by adding sine of 6 theta to both sides. I could say, oh, well, sine of 4 theta equals sine of 6 theta. You could try applying the sine inverse function to both sides, but you're going to run into issues. You're not going to be able to get all the solutions this way. You could conclude, oh, well, what if theta is 0, right? Theta equals 0. Hey, that's a solution. Yeah, but then you're not going to be able to get any of the other solutions. So this really just, this won't work to get all the solutions. So we have to do something different. I need to use a summed product formula. Okay, so I need to use the formula sine alpha minus sine beta. Sine alpha minus sine beta. This equals 2 times cosine of alpha plus beta over 2 times sine of alpha minus beta over 2. And in this case, alpha is 4 theta and beta is 6 theta. Okay? So, I'm going to replace this left-hand side with 2 cosine of alpha plus beta over 2, which will work out what that is in terms of theta, times sine of alpha minus beta over 2, which again will work out what that is in terms of theta, equals 0. So, 2 cosine, and I guess I'll write out long form for this one. So 4 theta plus 6 theta over 2 times sine of 4 theta minus 6 theta over 2 equals 0. Okay, so I've used the sum to product formula to manipulate the equation so that I have 2 factors rather than 2 terms. And this is going to allow me to solve the problem in a much more, well, complete way. This one, you get a number, but it's not complete, the complete solution. So, simplifying a little bit, this is 2 cosine of, when I have 4 theta plus 6 theta, that's 10 theta, divided by 2, I get 5 theta, times sine of 4 theta minus 6 theta is negative 2 theta, divided by 2, that's negative theta, equals 0. So this is much better already. Now, since sine is an odd function, this negative can go out in front. So minus 2 cosine 5 theta times sine theta equals 0. Okay, and then I can divide both sides by negative 2 if I want. So this reduces to cosine 5 theta times sine theta equals 0. So at this point, I need to use a trick from algebra. If you have a product in an equation, you have something times something equals 0, then you know at least one of those somethings has to be 0, or maybe both, potentially. So I know that cosine of 5 theta equals 0, or sine of theta equals 0. Okay, and I can solve these 2 equations separately. So we'll focus on this one because it's a little bit more involved than the other equation. So there's a couple ways to get started with this one. So what I'm going to do is this. I'm just going to say, well, on the unit circle, what 2 angles give me a cosine value of 0? Well, at the top of the circle, the x-coordinate is 0, and at the bottom of the circle, the x-coordinate is 0. So this would be pi over 2 at the top, right, and 3 pi over 2 at the bottom. These are the 2 inputs for cosine that produce 0 as a result. So I know that 5 theta, write that a little bit neater, 5 theta equals, well, either, there are 2 possibilities, pi over 2 or 3 pi over 2. Okay? Now, I'm not solving for 5 theta, I'm solving for theta, so I'll divide 5 on both sides, divide 5 here and here and here. The right-hand side has 2 levels to it. Hopefully that, we've done that before, hopefully that makes sense. So then theta equals, well, if I divide by 5 on both sides, that's going to be pi over 10 and 3 pi over 10. Right? Those are the 2 results of that way. So these are 2 solutions. These are 2 values of theta that when plugged into the original equation produce, well, not original, but the top of this column produces 0 as a result. But in cosine is periodic, as we've seen before, so I need to use the period of this cosine of 5 theta in order to find out, well, what values should I be adding to get the other solutions, right? So the period of any trig function is always going to be its standard period, which for cosine is 2 pi, divided by the angular velocity. In this case, the angular velocity is 5. Okay, so this is going to be 2 pi over 5. So I'm going to add 2 pi over 5. But you know what? Since I already have denominators of 10, I'm going to write this 2 pi over 5 as 4 pi over 10. That'll be a little bit more convenient for the calculations we have to do. So I'm going to add multiples of 4 pi over 10. So 4 pi over 10k. So k could be 1 or 2 or 3. I'm adding 4 pi over 10 some number of times. I'm adding the period some number of times. And I'll do that in both levels. 4 pi over 10k. All right. So now I need to remember that theta is in the interval 0 to 2 pi. Or if I want 0 to, what is that going to be? In terms of a denominator of 10, 20 pi over 10. Okay. So when I go to make my list of solutions, I'll have theta equals, well, pi over 10 is my first solution. It's the top. This came from the top of the circle back before we divided by 5, right? And then we divide by 5 and get pi over 10. So now if I add 4 pi over 10, well, that's going to be 5 pi over 10. If I add again, I'll have 9 pi over 10. If I add again, I'll have 13 pi over 10. If I add it one more time, I'll have 17 pi over 10. I'm adding 4 pi over 10 each time. Now if I add 4 pi over 10 again, I'll get 21 pi over 10, but that is greater than 2 pi, so it's outside the interval. So these are all the solutions. There's 5 of them. Well, you know, I'm sorry, that's half of them. I'm sorry. From for this equation, by using the top half here. We have to go back and do this again with 3 pi over 2. So the other possibility was 3 pi. Oops, 3 pi over 10. Yeah, 3 pi over 10. I misspoke there. Now, if I add 4 pi over 10, I will get 7 pi over 10. If I do it again, I'll get 11. You see, there are a lot of solutions to this equation. Many, many, many solutions. And these are just the ones from 0 to 2 pi, right? If I add 4 pi over 10 again, I will get 15 pi over 10. And once more, I'll get 19 pi over 10. So these are all the solutions, one of which can be reduced. 5 pi over 10 reduces to pi over 2. We won't bother doing that right now, though. Maybe we'll do it if we rewrite all the solutions. So these are all the solutions to this equation, just this left-hand side. We haven't dealt with this one yet, but this one's much, much easier, so don't worry too much. This is winding down. We're almost done. So, yeah, let's go back and refocus on sine theta over 0, sine theta equals 0 rather, but I'm going to put it down here. Well, you know what? That's going to cause us to write things twice. Let's not do that. We'll just go up here. We have room for it. Basically, on the unit circle, what values make sine into 0? Well, 0 and pi. And if I want 2 pi, 2 pi is equivalent to angle 0, so this would be 0, pi, 2 pi. Since the angular velocity is 1, we don't have to worry about the period because we've got all of them this way. So now I can just go amend my list and add to it also, 0, pi, and 2 pi. This is kind of a clunky list. Let's rewrite it in a somewhat neater way. So perhaps unnecessary, but I want to do it somewhat more neatly. So 0, we'll put them in order. 0 pi over 10. Pi over 2. I reduced the 5 pi over 10. 9 pi over 10. Pi. I've been going out of order. Okay, so hold on. This isn't super important, but I do want to get it right. I want to put them in order, basically. So 0 pi over 10, 3 pi over 10, 5 pi over 10, which is pi over 2, 7 pi over 10, 9 pi over 10, pi, 11 pi over 10, oops, 13 pi over 10, 15 pi over 10, 17 pi over 10, 19 pi over 10, and then 2 pi. So there's the full list of all the solutions to that original equation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 solutions to this original equation. So quite a lot of those.